Hello friends, welcome to AS Online. I'm here to give you some important areas of some uncovered topic in the syllabus of RRB JE Electrical. Already exactly 12 days back, we have conducted one live session on RRB JE for electricals, basic electronics. Yes, we can say it was part 1. And almost all the topics, whatever they mention in the syllabus, have been discussed. And I have given some previous year questions and expected questions also. But this is a session I'd like to tell you something which is not mentioned in the syllabus, that is the digital part. You cannot find this digital electronics topic wise or even subject wise in elaborated fashion in the main syllabus part, but you can find 2 to 3 questions in every paper. By inspecting the question paper, available question papers and with the historical data, I can tell you that around 2 to 3 questions are found in every paper on an average from the digital electronics. And that too, they are mainly focusing on some special topics like basics, a very basic level questions. So generally students will not prepare for the digital as it is not mentioned it in the syllabus, right? But I hope this session will definitely help you. That session can tell you that the important areas, what to read and what not to read. And my dear friends, myself Sriram, working in ACE Engineering Academy since 2014. Here I am taking digital electronics, analog electronics and basic electronics for GATE, ESE and public sectors. And you know, I am here to give you some information about the digital electronics subject and its weightage and important areas in RRB JE. My dear friends, you can find the similar questions, whatever the questions that we are going to handle here are in other public sectors also, like see KPTCL, APPSC, SSC JE also. This is the best comparison, SSC JE paper questions and RRB JE question papers, questions almost same. Okay, and not only that, AP Genco, Transco, KPTCL, TS Genco, in all exams you can find digital electronics as a one of the subject. So you can take the reference of those public sector unit undertaking papers to collect the questions, right? And as I told you, the digital electronics is out of the syllabus, but questions are found from some of the basic levels. Those topics are, see, these are the topics from here, questions are found. Sir, what are the basics? Strictly speaking, from the basic session, you can find the questions from switching circuits. The internal switching model of a OR gate, it was a question found. 2 switches, of course this question is recently given in TSPSC exam also. Switches are connected in parallel, 2 switches connected in series, like that the question was formed. In AND gate, series or in switches are connected in series from input to output horizontally. In case of OR gate, switches should be connected in parallel. If any of the switch is closed, output will be 1. So this is the model only, right? So this is a OR gate switch equivalent model. This question is found. Here they are giving sometimes some bulb symbol, otherwise you can find simply Y or X as output. A and B are the switches. If any switch is closed, output will be 1. It means this is a switching network which is acting as a OR gate. Like that, questions are found. Not only that, my dear friends, you should know the difference between positive logic, negative logic, and you should also know that how to write the duality. Simply I am writing dual and complement. Dual and complement of the given function. If you find one function f equals to ab or something like that, what is the main difference between dual and complement? My dear friends, in both the cases there is one common point, that is and or operators should be interchanged. In dual as well as complement form, you should interchange and or operations. And f equals to, for example, a bar b is a function. In that, let me take it here, f is equals to a bar b. This is one function. In this, a bar is one literal, b is one literal. In this function total, there are two literals. And rule number 2, while writing duality and complement is, in duality, you should not change the literals. You should write as it is. Whereas in complement, you should take the complement of that particular literal. My dear friends, I'm taking this as a function and I'm going to write its dual and complement. Let us assume fd represents the dual of this function and fc represents the complement of that function. I already told you that there is one common point for both dual and complement, that is and or operators should be interchanged. If you observe carefully, there is no or operation here, we have only and operation, right? Only and operation. So, dot will becomes or, and will becomes or, that's it. But you should write literals as it is in dual. You should write a bar as a bar, b as b only. But in complement, it's not like that. You should take their complements. A bar complement is a and b complement is b bar. This is a dual of this function. This is the complement of this function. Like that, there is a chance to frame the questions. Because these model questions are found in so many public sectors, right, as a basic level. Next, Boolean algebra. You should be aware of all the laws and theorems of Boolean algebra. Commutative law, right, associative law, commutative law, AB equals to BA or A plus B equals to B plus A. Associative law, A plus B plus C is equals to A plus B plus C. Distributive law, A into B plus C equals to AB plus AC. And De Morgan's theorem, this is very important. De Morgan's theorem, redundant literal rule, and consensus theorem. These are very, very important. Coming to the De Morgan's theorem, everyone knows that we can write AB bar as A bar plus B bar. Similarly, A plus B whole bar, we can write it as A bar dot B bar, right? But these two are something new for some students, because this is the daily routine everywhere. Once if you open the digital electronics, maybe in combinational or sequential, everywhere in different ways we are using the De Morgan's theorems. And redundant literal rule, it can help you to minimize the functions. Without this rule also you can minimize them, but if you could use this rule, you can save the time and you can skip so many number of steps in the minimization process. In this, we can derive so many relations, but mainly there are two. A plus A bar B is equals to A plus B, A bar plus A B bar can be resolved into A bar plus B bar. We have proof also for them by using normal basic Boolean algebraic methods, and by using the duality theorem we can do it. But I am not going to do any justification for the theorems and laws here. You just try to recall these things. A plus A bar B can be written as A plus B, and A bar plus A B bar is equals to A bar plus B bar. But you remember, my dear, in place of B, sometimes you can find one function. In place of B, assume A plus A bar into XYZ. Yes, we can write it as A plus XYZ, like that you understand. B means don't by heart as it is, and don't expect only B should be there. In place of B, it can be anything. It can be a separate function also. You can write A plus that function if you find in this particular format, right? This will definitely help you while minimizing the functions. Not only the PSU questions, you can also see these kind of minimization techniques like by using redundant literal rule in gate questions, okay? Right, and this is AB plus A bar C plus BC can be resolved as AB plus A bar C. We can prove it by using K-map in the concept of what we call RPI, EPI calculation. There we can remove this BC is nothing but actually RPI, redundant prime implicant. In that way we can minimize it, or we can add like here, see this is BC, you can add A plus A bar as a subscript. Then if you simplify it, you will get AB plus A bar C. There are different ways. These two ways are generally you can see in textbooks also while proving the equation LHS equals to RHS. Okay, so not only these things, I have written only important things. This is the direct question, and these two will help you for the minimization. So in that way I have written this. There are so many commutative law, associative law, and you should go for all the theorems and laws thoroughly, and you should also understand which logic gate is applicable for the associative law, or which logic gate follows the associative law, which logic gate follows the commutative law. These kind of questions are very popular from this particular area. Okay guys, next we'll see some of the simplification based questions. Actually, I have selected the questions only from your RRB JE. RRB JE questions are very simple and straightforward, especially from the digital, because they don't want to trouble you. They want to ask you the question from very basic level. As diploma based paper, they are giving the questions in the diploma based only from this particular subject. But in basic electronics part 1 means analog electronics part, it is not like that. Sometimes they are asking the simple numericals also. But this is not mentioned in the syllabus, but they are asking the questions, right? So that is the reason I am just giving you this information. And logic gates, this is very important, my dear friends. From logic gates, I have seen that in the recent 2 to 3 papers, in all papers, one question is found from the logic gates. You should be aware of all the basic gates. What are the basic gates here? AND gate, OR gate and NOT gate. These are called as basic gates. Everyone knows this. Then what about these gates? NAND and NOR gates. NAND and NOR gates are called as universal gates because we can implement any other logic gate as well as other Boolean expression by using only n number of NAND gates and only n number of NOR gates. That is the case. Actually, we need this type of design for IC fabrication. So that is the reason we are calling them as universal logic gates. We can implement entire digital system by using only with NAND or only with the NOR gates. Then what about the remaining 2 powerful gates? Those are exclusive OR gate and exclusive NOR gate. Exclusive OR and exclusive NOR gates are also called as, you people may think, sir, exclusive gates, sir, of course, okay, but we should call them as arithmetic gates, are also called as derived gates. In all arithmetic operations, you can see it might be a magnitude comparator, half adder, half subtractor, full adder or full subtractor. This will play, means XOR or XNOR play a vital role, right? So XOR and XNOR are also called as arithmetic gates. Again, there are 2 cases, my dear, direct 2 input XOR and XNOR and cascaded version. Of course, cascaded version questions are not found because it is only those questions are found for 2 marks in GATE and 1 mark in ESC papers. But I can suggest you can just go through at least 2 input XOR gate and XNOR gates. You should aware of 2 input XOR gate and 2 input XNOR gate. Just a basic idea is enough. XOR gate and XNOR gate. This 2 input XOR gate is also called as OR gate. OR gate. Sir, can I call it as even gate, sir? Yes, of course. As it is this, actually this name is, we can call the even gate only if it is having 2 terminals. 3 terminal case, that is different story. Excuse me. But we have one special name for exclusion OR gate, that is coincident gate. Remember, I am talking about 2 input gates. 2 input XOR gate is also called as OR gate. 2 input XNOR gate is also called as coincident gate. Whenever the inputs are same, output will be 1. Normal truth table basic operations are very easy, but sometimes questions are found like this. So from this particular unit, mainly you need to focus on basic level of universal gates. There are 3 levels actually in the universal gates. In that basic level is minimum number of NAND gates requires for NOT gate, AND gate, OR gate. Similarly, NOR gate requirement. You will get one table actually. Then functions will come to the picture. F is equals to AB plus C bar. Just example. Minimum number of NAND gates requires or minimum number of NOR gates requires. Such type of questions you can see only in gate paper and here and there in public sectors also. GENCO, TRANSCO, DISCOM and KPTCL type question papers. But in RRB JE, I don't think so. Definitely they are asked, because they are asking the questions from very basic level, so that definitely they will give you the questions from very basic level. So that as I given the hint, you should be ready to understand it. So first, by using NAND and NOR, I cannot give you complete circuit operation here, but my dear friends, you see, this table can definitely help you. NAND gate count requirement and NOR gates, number of NOR gates requirements. To implement all other gates such as, we have NOT gate, AND gate, OR gate and arithmetic gates, XOR and XNOR. XOR and XNOR. I think this table will definitely help you. We need only one NAND gate, even NOR gates also one, to implement an inverter or NOT gate. We need 2 NAND gates to implement AND gate, 3 NAND gates to implement OR gate, 4 NAND gates to implement XOR gate and 5 NAND gates to implement XNOR gate. So it is very easy to memorize. That is the reason I have given the table in a systematic way. But for NOR gate requirement is quite opposite in basic level as well as arithmetic level. In basic gates case, OR gates requires only 2 NOR gates. But AND gate, if you want to implement AND gate by using NOR, we need 3 NOR gates. But once if you remember this, it is very easy to memorize and recall the table. Very basic level, right? And here also same. We need only 4 NAND gates, only 4 NAND gates for XOR operation. But for NOR gates case, it is not 4, we need 5. We need 5 NOR gates to implement XOR. But we need only 4 NOR gates to implement the XNOR. So this table will definitely help you. But I can't give you the proof for these particular circuits, but I can give you this table, it can definitely help you, right? From this table also questions are found. And as I told you, not only from the table, from XOR and XNOR gates. Exclusive OR and exclusive NOR gates. Exclusive NOR gates. From here, you should develop some standard expressions. I told you that you follow only and focus only on 2 input XOR and XNOR. That is more than sufficient for you. and this is a IEEE symbol for exclusive NOR gate. XOR operation with complement will give you XNOR. And what is a XOR operation? The operator will be like this. So exclusive OR operation operator, let me erase it. Exclusive OR operation operators I am writing, and this is XNOR. Only in two input case XOR complement will be XNOR, XNOR complement will be XOR, but three input case it is different. Okay, but you in your primary level you focus on only two input XOR gates as well as XNOR gates, and the Boolean expression will be like this: A bar B plus A B bar for XOR operation, A B plus A bar B bar XNOR operation. I already written that somewhere in the previous slide. We can also call it as OR gate. For odd number of ones, output will be 1 in XOR gate. But here you can call it as even, but exam point of view, remember exclusive NOR gate is a coincident gate. We can call it as coincident gate. Let me take the truth table. A, B, I am writing symbol only, A XOR B, for all combinations of inputs. Similarly, AB, A XNOR B for all combinations of inputs. What are the outputs? You can substitute. If inputs are complemented to each other, then only output will be ones in XOR gate. But here, if inputs are same, that is the reason we can also call it as coincident gate. If inputs are same, you can substitute here, then only output will be 1, otherwise outputs are zeros. But my dear friends, I can't prove it, but I am writing it here. A XOR B is one function. If you take the complement of XOR gate always will give you XNOR. But remember, this complement operation is valid in two variable case. If the XOR gate is having two input terminals, then you can directly write it. 3 and more than 2 in the sense 3 or 4 or something like that, that is a different story. A cascading concept will come to the picture. Okay, right. A XOR B whole bar is equals to A XNOR B. You remember, and reverse is also possible. Complement of XNOR can give you the XOR. But here the main important points are like this. See my dear, for example, let me write X XOR operation with Y. X bar Y plus X Y bar. Sir, we know that and it is there on board. Again, why did you write it? Yes, I will let you know. You take A XOR A. Now this expression can help you. Substitute in that expression. In place of X we have A, even in place of Y also we have A. Actually no need to substitute, my dear friends. If in XOR gate inputs are same, output is 0, you can write it, or otherwise you can do this. So A bar into A, in place of X and Y we have A into A bar into A, 0 plus 0, 0. And we can bring this 0 left side, A XOR 0 is equals to A, it is possible. You can write like that. Or otherwise you can substitute. Everywhere or every time I don't substitute it, but you can substitute, my dear. In place of A we have X, in place of Why we have 0? That means what? You see, a bar into 0, 0 plus a dot 0 bar 1. So a dot 1 is a, so this is a. Like that, I will write all the important relations. Similarly, if inputs are opposite, a XOR a bar, then output is 1. From here we can write some other relations. A XOR, you take this one here, is equals to a bar, and similarly a bar XOR 1 is equals to a. But here the important relations are a XOR 0 is equals to a, and a XOR 1 is equals to a bar. Sir, why I should highlight these two relations? Based on these two relations, they are asking simple circuits there and framing the objective questions under XOR operations. Even you can do it for XNOR also. But for XNOR, I am writing directly. Now, be ready, my dear friends. They are giving the circuits like this and they are asking the name of the circuit. This is XOR with the input something like X, and one input is connecting to plus 5 volts. This is also XOR gate giving some input X, another input is connecting to ground, and they are asking the function of the element. X or A or Y, whatever, XOR 5 volts means logic 1. If one input is 1, you see, another input A, what did you get at the output? A bar. In this case, XOR gate is acting as NOT gate or inverter. XOR gate is acting as NOT gate or inverter. If one input is ground means what? 0. Okay, if one input is 0, A XOR 0, what did you get at the output? A. That means what? If one input is 0, whatever the next input terminal is available, that can transfer to the output. In this case, this element is acting as a transparent switch. It is just like a buffer. Output is X. What about this? X bar, and here it is acting as buffer. Right? So, here what is the main point? Exam point of view, there are 4 objective bits. Here I have given 2 objective bits, and XOR point of view, 2 objective bits. XOR can act as inverter as well as a buffer. Even sir, you can ask me a question. Sir, why don't you design inverter and buffer by using XNOR gate, sir? Yes, we can do. It is just quite opposite. Quite opposite. XOR XNOR gates truth tables are opposite. So the derived circuits also, or behavior of that derived circuits also opposite. Means if you take exclusive NOR gate, okay, one input is X, other input is connected to ground. In this case, it can act as inverter. Output will be X bar. And similarly, you take one exclusive NOR gate. You take one input X. I think you can guess what I am going to do. You can take 5 volts or logic 1. It can act as buffer. Quite opposite. Just quite opposite to the XOR gate. So, here 4 and 4 plus 2, 6 main important objective bits from this particular area. Like that, you take every topic and subtopic, find all the routine, common, repetitive objective bits and try to write the short notes. You no need to read the complete or GENCO notes or complete gate notes for RRB JEE preparation. You just go through the fundamentals and you try to solve the previous year question papers. That is more than sufficient, as the weightage of this particular topic is less as compared to others. Basic electronic weightage is more, but in the basic electronics, this digital part weightage is very, very less. That is the reason I am telling you this. Okay, right, my dear. And let me go for continuation part. So these are the important areas, and they are asking the questions from logic families. Actually, even in electrical gate syllabus also you don't have logic gates topic, but these questions are found only in SSC JE and RRB JE. You should understand what is a saturated logic. This is the recent question, of course, from SSC JE. But in RRB JE also questions are found from wired AND operation. So, you should know the classification of logic families. This is a basic and broad idea only, right? Let me give you some brief idea about logic families. Saturated logic families and unsaturated logic families. Based on this classification, recently question was found in SSC JE, saturated and unsaturated. Here almost transistors will operate in saturation. It's actually this classification is given in one standard textbook based on bipolar junction transistor operation, right? Here almost all logic families will come under saturated logic families like diode transistor logic, transistor logic. Generally in numericals case you can find DTL, but theory questions point of view TTL. What is the expected theory question? In TTL we have different types like basic TTL like open collector TTL and two-tempole TTL. In open collector TTL, wired AND operation is possible, and up to MSI level TTL is preferred in IC fabrication. So, I am writing in short. See, up to medium scale integration level, which one is the best logic family? TTL. Next, wired AND operation is possible. Wired AND operation is possible in open collector TTL. Strictly speaking, this is possible in open collector TTL. Possible in open collector TTL. Right. Next, integrated injection logic, also called as I square L, integrated injection logic. This is also popular for IC fabrication, but all are outdated. HTL, high threshold logic. In this logic family, noise margin is high. This is only objective bit. NM stands for noise margin. Which logic family is having highest noise margin? That is HTL. And NMOS, PMOS, directly I am writing MOS logic, and then CMOS. Very, very important. Fan out is more in CMOS logic family. Two objective questions are found from this repeatedly. Highest fan out is the question. No doubt this is the answer. Next most popular question, very low power dissipation. Low power dissipation means no second thought, you should write the CMOS logic family, right? And as compared to all logic families, see my dear friends, as compared to all logic families, left-sided saturated and right-sided unsaturated. Saturated logic families are slow logic families as compared to unsaturated. Power dissipation point of view, in saturated logic power dissipation is less. Overall classification. Among all, the lowest power dissipation means no second thought, CMOS logic family. Sir, then sir, what is the opposite? Opposite question means highest power dissipations are. In unsaturated, there are two types. Schottky TTL, TTL, and Schottky TTL is okay, but this is, I am giving 2 star marks, my dear friends, right? Schottky TTL means it is generally TTL with Schottky diode between base and collector of transistor. That TTL will become a Schottky TTL. But the most important one is, you better to take multiple stars here, emitter coupled logic. Of course, both are having almost the same specifications, but as compared to this, ECL is the fastest one. Emitter coupled logic is the fastest logic among all. There are so many logic families, among all, it is the fastest one. Indeed, Schottky TTL as well as ECL, both are the fastest logic families. Then sir, what about the power dissipation? These are two objective bits from ECL. High speed, not only that high speed or fastest, that is one objective bit, but another point is power dissipation point of view. It should be something special as compared to all, then only they will frame the objective bit. This is very special, the power dissipation is very high, more power dissipation. Among all, of course, these two will take more power, but as compared to all, ECL will take or dissipate more power because it requires two power supplies, right? Collector side and emitter side. This is emitter coupled transistor, right? So these kind of questions, there are so many: package density point of view, figure of merit point of view, figure of merit numericals point of view. They are giving speed and propagation delay value, you should take the product of them. And fan in, fan out calculations, fan in, fan out values, IC numbers. These kind of questions are found from the logic families, but I told you, I am just giving you the basic idea and directions. The students can understand how the questions are going to frame in our exam from this particular area, right? So, coming to the next topic, this is about something about the logic families and important areas. Coming to the radix conversions. From radix conversions also, this is most important here. See, logic families, logic gates, radix conversions, and complex numbers or complement numbers. From these areas, repeatedly the questions are found from these areas. But you focus on all these selected topics. This is not the, even it is not a 20% of digital electronics. It is just 10% of digital electronics. Remaining 90% is nothing but ADC and DAC, analog to digital and digital to analog converters, FSM, finite state machines, sequential circuits, combinational circuits. This is a major part of digital. From this major part, no questions are found. I already told you. This is a information I am presenting by inspecting the historical data of recent RRB JE exams, as it is not given clearly in the syllabus, right? So as it is not mentioned in the syllabus, they are able to focus on basic areas only. They don't take the questions from the design part or major conceptual topics of a digital part. So it might be a reason the questions are found from these areas. Again, in these areas, 3, 4, 5, 6 are very important. At least you should have a look over these particular subtopics. Okay? Coming to the radix conversions, you try to separate the conversions completely. Decimal to others and others to decimal. So decimal to others means I am writing radix number only, base value, binary, octal, hexadecimal, that's all, and others to decimal. So in this way, you better to practice these things. After that, you can find binary to octal hexa and reverse, octal hexa to binary. From this area, maximum 100% questions are found from this area only. Others to decimal, there is a standard polynomial, we should substitute the values. Decimal to others, whatever the other radix, whatever 2 or 8 or 16, you should divide that value in the decimal number with that radix. You should separate quotient and remainder, you should collect the numbers, right? Last quotient to all the reminders. That is the procedure, okay. But other things means these are only 6 conversions. Decimal to binary, decimal to octal, decimal to hexa, 3 and reverse 3, 3 plus 3, 6. Total number of conversions 12 actually, right? So binary to, this is very important, hexa and binary to octal. This is simple actually as compared to this. but they are asking these questions only. This is very simple as compared to this. Okay, only for RRB JEE level and Genco Transco also. For gate level, completely different story. They don't ask you already available standard number system. There are some logical questions, right? And reverse, hexa to binary and octal to binary. This is octal, okay? Octal. Hexa to binary and octal to binary. How many? 4. Sir, you said there are totally 12, sir. 6 over, 4 over, 6 plus 4, 10 over. And now the next one, octal to hexa and reverse 2. But here, if you want to solve the question, you should know binary to hexa, hexa to binary, binary to octal and octal to binary. This is important because you cannot go through octal to hexa directly, and you can go through decimal, but it is long procedure. You better to use the binary as an intermediate level. You go to the binary and then binary to hexa. Again come back and here to octal. This is a best and correct and simple way. So that, my dear friends, for example, if you want to convert some binary number 1 0 1 0 1 1 1 0 something, example, just example only, okay, right, 0 0 0 0, this is a binary number. To convert this binary number into hexadecimal, I can't explain the proof, procedure, system, we don't have that much of time. I am directly giving question and answer with a simple explanation. I want to convert it into hexadecimal, first example. And same number I want to take 10 10 111 00 000 I wrote over there. You can take any number, no issue. And how to convert the same number into hexa is already written, octal, and reverse also possible. Right. See this, while converting binary number into hexadecimal, you should start from here, rightmost bit, only the integer part, there is no fractional part. If you find the fractional part, you can start from here like this. And 16 is equals to 2 power 4. You just group 4 bits in binary and make it as a single digit in hexa. I think you got the point. Binary to octal case, you need to group only 3 bits of binary, make it as single digit in octal. In reverse process, should take care of that. If you want to convert 1 digit in octal to binary, you should distribute that in 3 different bits form. For example, you want only 1, you cannot write simply 0 1, you should write 0 0 1 only, right? Like that, you do the reverse operation also. That's it. So 1 2 3 4, 4 bits, 1 2 3 4, 4 bits, and these are 4 bits. 1 0 1 0, we are in hexa, right? We are going into the hexa, means 10. But how to write 10 in hexa? A. 1110, 14, E. And all zeros, of course, it is 0. For example, if it is all ones, F, like that. Similarly here, group 3 bits at a time. 5, 3, 4, and 0. 5 3 4 0. 000 0, 1 2 4 4, 0 1 1. See, this is 0 1 1, right? 3 and 1 0 1 is 5. Reverse also, you should write 0. Sir, this is 0, this is also 0, this is also 0, this is also 0. While you are converting octal 0 into binary, you should write this. While you are converting hexadecimal 0 into binary, you should write this. You should write like this. Okay? Please keep it in mind. So that is the reason, if you want to convert octal to hexa, it is easy. For example, this is octal number. If you want to convert it into hexa, you take this number, octal number, convert it into binary. then you group 4 bits at a time, then you will get back the value into, you will get the value in hexadecimal. Like that, octal to hexa or hexa to octal, you better to use a binary step in between them, so you can easily go with that. Right, these questions actually, why I have given this example, why? Because these questions only found. Actually 3 questions are found. I will give you one question now. All 3 questions are from octal to hexa only. I think one question is from hexa to octal. Okay. Now, complement numbers, complex numbers or complement numbers, here mainly 2's complement. 1's complement, you should know the range, it's okay, but all numericals are found from 2's complement number system. All numericals are found from 2's complement. They are directly asking you the 2's complement value of so and so number. So, if they are asking the value, you should take care of this sign. If they are asking the straightforward conversion like some binary, write it in 2's complement, then you no need to look at MSB and LSB, you can directly write it's 2's complement. But how to write the 2's complement is a task. And range formulas are very, very important for unsigned magnitude number, signed magnitude number, 1's complement and 2's complement. For all these 4 systems, you should know the range formulas. They are asking only 2 questions. One, range formula, very rare cases. Second, they are asking the 2's complement. And next, data codes. In the data codes, mainly they are focusing on binary to gray and gray to binary conversions. Only they are focusing on binary to gray and gray to binary conversions. Right, these questions, because these questions are found. That is the reason I am highlighting these things. You better to know something more about these particular subtopics. Right, if you learn more, you no doubt you can do well. Okay, my dear friends, coming to the some basic information about a complement. You know how to write 1's complement and 2's complement. For the given binary number. If I give you the binary number like 0110, very easily students can write the 1's complement just by interchanging the numbers. I am not going to give you the formula or why we are interchanging the numbers, proof and all. Directly I am following the simple technique, whatever the method that you are using. We are interchanging 1's and 0's, automatically the number will be appeared in 1's complemented form. That's all. So, it will becomes 1001. This is in 1's complement. Easy. But if I ask you to represent the same number 0110 in 2's complement, generally students follow this method. First they take it in 1's complement. After that they add 1. Remember in 2's complement, if you get 1, I mean if you get end around carry, 1 in the sense carry. If you get an end around carry while doing additions or any arithmetic operations, keep it in mind, you should ignore the carry, end around carry, carry from the last bit, okay, carry from the MSB bit. If you get MSB bit, carry from MSB while doing operations or arithmetics in 2's complement, we are ignoring it. So, general method, I am writing it as method 1. How the students are writing 2's complement value? First they are writing 1's complement for the number 1001, and after that they are adding 1 to the result. 1 plus 1 0 with the carry. With the carry, this is not end around carry, okay, this is intermediate carry. 1 plus 1 0 with carry 1. So that carry plus 0 is 1 and remaining number 0 and 1. So 1010. This is a 2's complement value. This is a 2's complement value of 0110. But you no need to do like this, my dear friends. You can save the time by writing the 2's complement. There are different ways. This is one of the best way. You just take the number and just try to observe the number from the rightmost bit with respect to your hands, right hand, okay, rightmost bit, right. So, I am writing the given data 0, 110 and copy the bits from the right side, strictly speaking from LSB side, till to get first time 1. Seek the values till to get first time 1. So, first time 1 is this, right. So, you copy it as it is, 0 copied, 1 also copied, and complement remaining all other bits. These are the other bits, complement them. 1 complement is 0, 0 complement is 1. That's all. This will becomes the 2's complement. 2's complement of 0, 110 is 1010. You already knows that you have done this by using your general procedure. By writing 1's complement, you are adding 1, you got 1010 is the 2's complement of this number. So, 1010 is the 2's complement of this number. You better to use this method, you can save the time, okay. Right. This is a point I wanted to give you just in the basic level, right. Now, gray conversion. I will give you one basic idea about the binary to gray and gray to binary conversion also. See, binary to gray. Binary to gray conversion. Let me write some numbers like example 0, 1, 0, 1. This is a MSB bit in binary. You take it as B3 and this is B0 obviously. You just drag the MSB bit here, write it as it is and add every subsequent bits and ignore the carry, that's it. 0 plus 1, 1 only. 1 plus 0 is again 1 and 0 plus 1 is 1. Add subsequent bits and produce the output, I mean gray number. This is G3, this is G0. This is a procedure to convert binary to gray. Let me explain gray to binary conversion. Let me take 0, 111. So, it can be G3, G2, G1 and G0. Here also step 1 is same. As it is, whatever the MSB bit in gray, you can take it as MSB in binary, B3, and add the diagonal numbers 0 and 1. And as usual, ignore if you get carry. Luckily here we don't have carry. So, 0 plus 1, 1. Then what about this 1 plus 1, 0 with carry, ignore the carry. So, that 1 plus 1, 0 you can write it here. 0 plus 1, you can write 1. So, B2, B1 and B0. 0, 1, 0, 1. Yes, we know 0, 111 is a gray code equivalent of a binary 0, 1, 0, 1. So, 0, 1, 0, 1 is obtained. So, this is a method to convert binary to gray and gray to binary. You use the methods, you will get the answers. And my dear friends, generally students regularly ask the common questions like, sir, what is a source or reference? Actually, for this particular subject, I can tell you material. You can take any material, available material, or at least you take one basic level textbook. Luckily, if you have notes, if it is a Genco notes, because we are conducting generally offline Genco classes. So, generally majority of the people having Genco offline classroom notes. Are the students who are already joined for RRB JE-EEE, SSC JE-EEE or public sectors in recorded version, They also have the PDF notes provided by faculty or their handwritten notes, any notes. Okay, but our semester exam notes may not help you because their orientation is different. You cannot find that much of shortcuts and all. So this objective, strictly speaking, the competitive courses based notes will definitely help you out. Next, textbooks. Actually, I don't recommend any textbook for this because questions are from very basic level. You don't have that much of time. Even if you are interested to read all, it takes more time. It will kill your valuable time. But safe side, if you are interested, you can take Morris Mano, any recent edition, right? That is more than sufficient. And as I said earlier, by inspecting the recent papers, I found that they are giving 2 to 3 questions. Obviously 2 to 3 marks are found. And 2 times I think only 2 questions are given. That too, both the questions are given from logic families, right? So logic families, you will have lot of theoretical data. So that is the reason for them also preparing that objective theory question is very easy from logic families. Okay, and okay, we'll see just 1 or 2 questions and you try to answer this question. The octal representation of AOE base 16 is. I want to represent it in octal. The octal representation of hexadecimal number. I have given example already, but numbers are different. That is only the story. Okay, procedure is same. Okay, you verify, you convert this number into binary by writing this each digit in 4 bits, 1010A, 0000, I mean 0, E1110 and group them 3 bits, you will get 5016. 5016 in octal. You verify it, you will get option A. Consider xy as binary variables. Actually, question format is missing here. This is a function. This type of questions are found from Boolean algebra. Very simple and straightforward. X into x plus y bar. X plus xy bar. X is common, right? And these all are the RRB JE questions only. We don't have time actually. I have collected some questions from ISRO and SSC JE, but as I said, SSC JE questions are little bit complicated and interesting as it is an official syllabus. And especially in public sectors, electrical students, you better to choose the BARC previous papers. You better to solve the BARC papers, right? You can find logical questions, but here questions are very simple, straightforward. Even you no need of 5 to 10 seconds also to solve these questions. Because intentionally I have collected these questions because these are the previous RRB JE questions, right? Now, 2's complement of binary number, some binary number is given. Whatever the method you want, you can use. You use method 1 or method 2. 0000 1111 is a binary number, right? So we want to write its 2's complement value. We want to write its 2's complement value. I think you may remember the procedure. You can take 1's complement and add 1. It's okay, or otherwise you can directly write. Select from right, first bit itself it is 1. So copy it and complement all. That means 1111 0001 will be the answer. Even you can do like this, ones complement, 4 ones, 4 zeros, add 1, 4 ones, 3 zeros plus 1, that's it. So that 4 ones, 3 zeros, 1, 4 ones, 3 zeros and 1, this is the option. This is the recent question, electrical RRB JE, right? Okay, just I already told you that this is a session to motivate you and to give you the directions, and you should know what to read and what not to read. So to give you the direction and motivation only we are conducting this session. Otherwise entire subject is not possible to cover in 1 hour, right? I hope this session